Now we're going to do this integral. And something similar is going to happen as in the previous integral, though not as tragic. So if you look at the integral, x equals 1/2 to 2, that's the outer integral, sorry, that's it, 2. And on the inside, we have the integral y equals 1 over x to 2 y cosine xy dy and then dx on the outside. Okay, to do the inner integral, we're going to have to do kind of a tedious integration by parts. It's straightforward, but it's going to be kind of aggravating. And it might actually give us a pretty difficult integral that we have to compute when we come to the outer integral. So what we want to do is see if there's some way this 1 over x and the y, maybe if we switch the order of integration, maybe somehow these two things will cancel and we'll have an easier integral. So that's what we're going to do. We're going to switch the order of integration, but to do that, we need to go to Desmos because, aside from the previous problem, all the other problems, I gave you the region, and then you had to come up with the limits. But on these problems, I'm giving you the limits. You have to come up with the region, and then you have to change the order of integration. So let's go to Desmos now. Okay, so this is the region. This depicts the region that we want to integrate over. It's similar to the one from a couple problems ago. So y equals 1 over x to 2, and x equals 1/2 to 2. So this is the region that we're integrating over right there. And the hope is that if we switch the order of integration, we'll get an easier integral to do. So if we switch the order of integration, y is going to go from here to here. And for every value of y, x is going to go from 1 over y to 2. So x goes from 1 over y to 2. And then y will go from 1/2 to 2. Okay, so now if we look at the inside integral, well, the y is a constant, so we can pull the y outside, and then we're just left with cosine of xy. Now, the antiderivative of cosine xy with respect to x is 1 over y sine of xy, and we're evaluating this from x is equal to 1 over y to 2. And this is the integral from y is equal to 1 over 2 to 2 y times, well, if x, notice that the y and the 1 over y cancel, so really that goes away, and so we're just left with sine of x times y. So this is going to be sine of 2y minus, if x is equal to 1 over y, this is minus sine of y, or sine of 1 dy. Okay, so the antiderivative of sine of 2y is minus 1/2 cosine of 2y. So then this is going to be over 2. So this is going to be cosine of 1 minus cosine of 4 over 2. Now sine of 1 is a constant, so this is going to be minus 2 minus 1/2, which is 3/2 sine of 1. And there's really nothing more you can do with this answer. Okay, so in this way, we could have done it if we had the x integral on the inside, but it was just better to have to do it this way. I'm sorry, we could have done it with the y integral on the inside, but if we do it with the x integral on the inside, we avoid having to do integration by parts, and we just get a much easier integral to do. So this way, clearly, it's better to do the x integral on the inside. So when you're doing a problem, it's not always apparent. I'm not always going to be there to tell you which order of integration to do. Basically, with experience, you'll start to see, hey, wait, maybe the problem is set up in such a way that it's easier to do the integral in the order that it wasn't given me. But remember, to do this, you really have to draw the region. You have to sketch the region, because changing the order of integration usually involves something a little more than just swapping the integrals around. Okay, you have to really make sure that you change the order of integration in the right way. And we'll see more examples of this as we go on.